Why can two electrical systems deliver the same active power, while one carries much more current? A common reason is reactive power. Let us see what it is, why power factor matters, and how compensation helps. The power triangle connects three quantities. Active power, P, performs useful work. Reactive power, Q, supports magnetic fields. Apparent power, S, is the combined demand carried by the electrical system. Power factor equals P divided by S. Motors and transformers are inductive loads. They need reactive power to establish magnetic fields, even though that reactive power does not become mechanical output, heat, or light. The upstream network still has to carry the associated current. When power factor is low, more current is required to deliver the same active power. That additional current passes through cables, transformers, switchgear, and panels, contributing to losses, voltage drop, greater loading, and less available system capacity. Compare the system before and after compensation. Active power remains the same. Local compensation reduces the reactive power drawn from upstream, shortens the apparent power vector, improves power factor, and reduces the current carried by upstream equipment. The basic principle is to supply reactive power close to the load. The correct method depends on voltage, load variation, harmonic conditions, required response speed, protection, and cabinet design. There is no universal solution. For a relatively stable load, properly selected power capacitors can provide fixed compensation. Capacitor ratings, voltage, temperature, duty, switching conditions, and the surrounding harmonic environment must all be reviewed before installation. For changing loads, an automatic compensation controller monitors system conditions and switches capacitor steps according to demand. The controller, switching components, protection, and step arrangement must be coordinated as one complete compensation system. Smart power capacitors integrate compensation, measurement, protection, switching, and control functions into modular units. They can simplify cabinet design and installation, but product selection still depends on the actual system data and application. When loads change rapidly, a static VAR generator, or SVG, can provide faster dynamic reactive power compensation. The required capacity and response strategy should be determined from measured load behavior, not from a generic target alone. Harmonics can change the design. Drives, rectifiers, UPS systems, welding equipment, and other nonlinear loads may increase capacitor stress or resonance risk. The solution may require series reactors, an active harmonic filter (SVG), or a coordinated combination. Before selecting equipment, provide system voltage, load, or current data, present power factor, load variation, harmonic measurements, target power factor, cabinet information, and the single line diagram. Send your system data to YORA Electric for technical selection support.